nutritionist wants to estimate the difference between the proportion of males and females who consume the USDA's recommended daily intake of calcium. What sample size should be obtained if she wishes the estimate to be within 3 percentage points with 95% confidence, assuming that she uses the results of the USDA's 1994 through 1996 Diet and Health Knowledge Survey, according to which 51% of males and 75.2% of females consume the USDA's recommended daily intake of calcium. So the formula for this is that the sample size of both populations, sample size of both samples, I should say, are supposed to equal to P1 hat times 1 minus P1 hat plus P2 hat times 1 minus P2 hat that whole sum times the z-score sub alpha divided by 2 divided by the margin of error, and we're squaring that fraction. And like the previous times that we've seen sample sizes, we want to round up. Round up with an exclamation point. So here we were given the values of P1 hat and P2 hat. If we let the males be P1 and females be P2. So the sample size, writing this entire equation out, this will be 0.511 times 1 minus 0.511 is 0.489 plus 0.752 times 0.248. Okay? And that'll be times the z-score for 95% confidence. This will be 1.96, which, you could check that if you wanted to, divided by the margin of error of 3 percentage points, so 0.03. And we're squaring that fraction. If we toss this into a calculator or Excel, we get a value of about 1,862.6, which we would then round up to 1,863. So just to write out a sentence explaining that sample size, the nutritionist needs to sample 1,863 males, randomly selected males, I should specify. Randomly selected males, and 1,863 randomly selected females. If she does not use a prior estimate, then this formula is a little bit less complicated. This entire sum is simply 0.5 that maximizes this sample size. So without prior estimates, this entire thing is 0.5. So 0.5 now times that z-score of 1.96 divided by the margin of error of 0.03. And we're squaring this. If we do this, the maximum that this is going to be is 2,134.2, which we would then round up to 2,135. So the maximum sample size that that nutritionist could use is 2,135. But to write that out as a nice fancy schmancy sentence, this is going to be the nutritionist needs to sample 2,135 randomly selected males and 2,135 randomly selected females.